Okay, so today I am going to talk about web packets. Okay. So far I have been talking about plane waves. Plane waves means it has a single component of four momentum, well-defined four momentum, energy momentum, right? In non-relativistic quantum mechanics also, we initially talk about plane waves. We know that those plane waves of the form of e to the power I kx, say, are not normalizable wave functions. You know that, right? So for that, what you do is superpose different plane wave states with suitable amplitudes, which are also dependent on the momentum, and then we form what are called wave packets. Just to go back to the non-relativistic theory, you have e to the power I px. I am doing in one dimension. This is just a recapitulation of your non-relativistic quantum mechanics. Non-relativistic quantum mechanics. E to the power I px. If you have a wave function of this form, you know it is a well-defined momentum. The momentum uncertainty is 0. Delta p is 0. So delta x is infinity. There is no knowledge about the x coordinate. It spreads from minus infinity to plus infinity. Right? This is a train of wave from minus infinity to plus infinity. You can visualize like this. But then how do I form a wave packet? I consider, means I superpose e to the power I px with some coefficients, say AP, and integrate over p. So I superpose different plane waves. One with means if the momentum changes, so the momentum is related, you can do h bar k, you remember. Momentum is related to h bar k. So k is 2 pi by lambda, so h bar 2 pi by lambda. So if momentum changes, lambda is the wavelength. So if the momentum changes, the wavelength also changes, right? So when I say that I am superposing different momenta, I am superposing waves of this type having different wavelengths. Okay, so one wavelength, one may be like this. So there is a continuum of waves labeled by either momentum or the wavelengths. What we want, the wave packet typically, I am not going to details, you should read elementary books of quantum mechanics if you don't recall, that this superposition should give rise to wave packets such that, roughly speaking, they should give rise to some sort of shape like this. So, shape like this, okay, so that there is a destructive interference outside some region like this and constructive interference here. Okay, so the total wave after integrating should survive at some region, finite region, and should be vanishing elsewhere. That's how I get wave packets. I superpose. Okay. For example, you can see that if you just if you just consider this e to the power I px dp, just this thing. Okay. AP is a constant factor, it's independent of p. I have taken this out as a constant. This is the simplest example you can think of. To superpose plane waves like this, where x, you can clearly see it will have some x dependence after integration, and momentum is being integrated from minus infinity to plus infinity. Okay. So I want to visualize what this kind of superposition will give. Okay. Just to give you an example, let's see what happens at x equal to 0. I call it psi of x. I define it like this. This is my defining relation. Psi of x is like this. Okay. So now at x equal to 0, psi of 0, you see it is minus infinity to plus infinity dp, because x equal to 0, it is 1 and it's just dp. And this diverges. But x equal to 0, this diverges. Right? X not equal to 0, say psi of a, it is not equal to 0, what it will be? It will be e to the power I pa dp, minus infinity to plus infinity. Okay. Now I argue heuristically that when you superpose such plane waves, because now again p varying continuously from minus infinity to plus infinity with a is not equal to 0. So now suppose I have one p and another p which is p prime, which is equal to p plus pi by a. Out of this many, means infinite number of plane waves, I choose two plane waves having momentum p, another is p prime. Let's see what it is. E to the power I pa, another will be e to the power I p prime a. Isn't it? So I pairwise combine them, shifted by this amount. So what it will be? E to the power I pa plus e to the power I pa times p prime a, so pi. E to the power I pi will give you minus 1. So e to the power I pa minus e to the power I pa, that will give you 0. Okay. So what do you get? You get that there is a pairwise destructive interference at any point outside x equal to 0. Okay. So at x equal to 0, this object diverges. This is x-axis. X equal to 0 diverges at any point x equal to a not equal to 0. This is 0. So there is some function. This is such that this is equal to infinity at x equal to 0 and 0 at x not equal to 0. Okay. And this is nothing but your delta function. So delta, that's why integral representation of delta function comes like this, up to a factor of 1 by 2 pi or something like this. Right. So this is some heuristic way of understanding this. There is an extreme case where the particle is sharply localized at this point. Here it is just the opposite. Here delta x is equal to 0, but delta p is infinity. Because there are all possible momenta being taken into account. You don't know, and with equal weightage. All for AP I told you is independent of P. So equal weightage. I do not discriminate between this plane wave, that plane. All of them contributes equally. Okay. So here uncertainty in momentum diverges. Uncertainty in x is sharply 0. Just the opposite dual case. Okay. So now I am going to say that I will insert some AP, which is not constant but depends on the function. And that is actually will be the Fourier transform of this. That's what is meant by. And once I do this, I can ensure that this neither plane wave like this, which extends from minus infinity to plus infinity, which I drew earlier, nor a delta function like this, something in between, okay, which will have some sort of shape like this, as I told you. So that both delta x and delta p's are finite, and their product will always be greater than or equal to h bar by 2, fulfilling the Heisenberg's uncertainty relation. Okay, so far it is clear.
আপনার আগের এক্সাম্পলটা যেটা পেয়ারওয়াইজ ক্যান্সেলেশন, ওইখানে হচ্ছে মানে আপনার মানে শুধুমাত্র at x equals to 0 তে যখন এটা লোকালাইজড হচ্ছে সেখানে হচ্ছে মোমেন্টামটা ইনফিনিটি হচ্ছে, আর আরেকটা যেটা বললাম ওটা টোল নাকি বাইরে রিজিয়নটা হচ্ছে এটাতে উল্টো দিতে হচ্ছে
কোনটা?
মানে at x equals to 0,
x equal to 0, the another point at x equal to not equal to that point I have taken to be a, psi a not equal to 0. সেখানে e to the power I p a integration over p. So I take, there are whole infinite number of plane waves, all labeled by their respective momentum p. Now I take two of them, e to the power I p a and e to the power I p prime a, where p prime is equal to this thing. This definition is meaningful because a is not equal to 0. Okay, that's why I segregated the two cases. One case where at the origin, another away from the origin. The moment you are away from the origin, you always can have this kind of pairings, and you can see that they give rise to 0, so gives rise to destructive interference. So the plane waves will interfere destructively away from the origin, both in the left and the right, and will interfere constructively at the origin. So the particle will be sharply located at x equal to 0. Okay. Here I have considered smoothly varying function of momentum, which interpolates these two extreme situations. Okay. So here you have smoothly varying function. I take its Fourier transform also will be smoothly varying function. Okay. Okay. And here you will have both delta x will be finite, and delta p also will be finite. Okay. And their product automatically will satisfy delta x, delta p greater than h bar by 2. This you know very well. I have just recapitulated how you form. Okay. So now let me come to the situation for relativistic wave packet. So that's how wave packets are formed, where these are wave packets. Okay, typical wave packets. And wave packets have further virtue that they are square integrable. Psi x mod square dx minus infinity to plus infinity will be same if you take the Fourier transform correctly. Will be same as this AP dp AP mod square minus infinity to plus infinity. Both will be same and they will be finite. And this is why we call square integrable functions. They're square integrable. I say psi of x belongs to L2 R1. In my case, I am considering one dimension. I have just erased it. So it is square integrable function on the real line. ঠিক আছে? Likewise, AP also will be square integrable functions on real line. But this real line will be the position real line, and P will belong to the real line, which is the momentum space. One is a coordinate space, another will be the momentum space. And this equality, you know, this is known as Percival's theorem. Is that it? We have studied these things. So now I want to form a wave packet in the relativistic scenario with the Dirac equation. So the spinors will come, and I likewise superpose the momentum states, but now the momentum is a 4 momentum. And here is another new feature which was absent in the non-relativistic case, is that now here we have negative energy solutions also. So let us first consider a superposition of positive energy solutions, just positive energy solutions. Let's say finite. Okay. So I write psi plus of x, okay, and I integrate over momentum d3p by 2 pi cube. I'll explain very soon. I'm inserting the factor of m by e. It's a dimensionless number, and then integrating alpha equal to 1 to b p alpha u p alpha u alpha p this is the 4 product. Okay, u alpha p are the so-called polarization spinors, which I have introduced. These are up to this, they are the plane wave solutions. Okay, and earlier I wrote in the AP, that will be now this thing, but now the additional index alpha will come, the polarization index, spin up or down, that thing will come. Okay. So you have to, this is a new feature. Regarding this thing, I have to integrate over the entire 3-dimensional momentum space. That's true, but it should be Lorentz invariant. And with this, m is anyways a Lorentz scalar, rest mass of the particle. You don't have to bother. E should be there in the denominator to make it a Lorentz invariant measure. I hope Shayan or Partho must have explained it, so I need not repeat it. Okay. And m I have just introduced because if the particles move very slowly, E is almost equal to m, right? Because rest mass is too high. So this factor in non-relativistic limit will be almost close to 1. That's why you recover the non-relativistic formula. Okay. And to means also the purpose is served by the presence of m, because this factor is a dimensionless number. Okay. So remember, this integration is being done on a mass shell, as I told you earlier. To draw E versus P, one dimension, then this is the mass shell. So here I have drawn the one dimension. So I've just suppressed other 2 dimensions. So these satisfy E square minus P square equal to m square. This is the hyperbola you get. Okay. So dp means you consider an element of this sort, infinitely small, but you have to divide it by the corresponding energy. To take infinitely small interval, call it dp, but means it is so small that you can associate uniquely a value of E corresponding to it. So if you go there, so another dp, you have the corresponding E here. Where this dp is located in this hyperbola, this way, wherever it is located, it will be associated with the corresponding E, and that E you have to put it in the denominator to ensure that this measure is Lorentz invariant. Okay. So now I have written, you see I have not included the V part because U's correspond to the positive energy solutions, U1, U2. V1, V2 are the negative energy part. Okay. So now I want to calculate the probability density and eventually the total probability. So I'll try to calculate d3x, d0x. So this will be d3x, j0x is psi plus dagger, j0 is psi dagger psi. Okay. Okay. Is okay? Means J mu was psi bar gamma mu psi. So J0 will be psi bar gamma 0 psi. Psi bar is psi dagger gamma naught. Another gamma naught here. Psi. Gamma naught square is 1, so it will be psi dagger psi. Okay. You see, psi bar psi is a Lorentz invariant quantity. I approved. Psi dagger psi is not Lorentz invariant. E by m factor comes because it is expected. It is a probability density. J0 times this thing is Lorentz invariant because this part undergoes length contraction under Lorentz transformation. 3 volume in the direction of boost. If it is boost along the say x direction, there will be length contraction in the x direction. Y and z will remain unaffected. And z0 will transform just oppositely. E by m. That will cancel. So the total probability will remain same. Integrated probability. Or the probability density you can say. This is the probability density times d3x. The probability between x and x plus dx. That will be invariant a Lorentz transformation. The probability density part will not remain invariant because it is a special relativity. Okay. So this I need to calculate now. So now I just substitute it here. So d3x, let me do it carefully. Now psi dagger x. So let me write d3p. There will be another integration d3p prime will come, and there will be a factor of 2 pi to the power 6, and there will be m square. There will be E comes with p, then E prime will come with p prime, right? Another in terms of the prime variable, you have alpha beta is equal to 1, 2. So there will be two summations, one for alpha occurring here, another, I call it a different dummy index beta. Okay. So for these things, B dagger, P alpha, okay, and U alpha, P e to the power minus I P dot x, and it's a dagger, so U alpha dagger. B alpha is a coefficient, so I should put a star, indicate the complex conjugate. It should be U alpha dagger, okay? And then, so I have taken the dagger of whole thing, right? This thing, this thing, this thing. Okay, now I put this thing, so I put B, P prime beta, right? I have a different W index now.
Sir,
Huh.
so e to the power plus x. Sir, exponential টা
হ্যাঁ exponential টা বলো
স্যার যখন ড্যাগার নিলাম প্লাস
plus right correct correct me whenever I go wrong right p prime beta u beta p prime e to the power minus I p prime dot x. Okay. Is it clear? Now, let me do this integral over d3x first. d3x occurs, when x occurs here as well as here, nowhere else, right? So, and also 2 pi to the power 6, I bring it out, 1 by 2 to pi to the power 6, integral d3p, d3p prime, by E prime m square summation over alpha beta is equal to 1 2 b star p alpha. These are numbers, so I can bring them here, b p prime beta. So just bring it there, and u, now u alpha dagger p u beta p prime, and then I put the integration d3x e to the power I minus I p prime minus p dot x. Is it okay? But you remember, this part actually contains the 4 product, 4-dimensional, Minkowski dot product. Okay, here integration over just 3-dimensional thing. Okay, so now let me just focus on this integration, d3x e to the power minus I p prime minus p dot x. Okay, so what you can write d3x I p prime 0 is nothing but e prime, right, minus p0 is e t minus p prime, this is a 3-vector product, dot x. Okay, so now focus on this thing. This part will go out of the integration, only this part you can retain. So you can write e to the power minus I e prime minus e t integration d3x e to the power I p prime minus p 3-vector. This is a 3 product dot x. And this just Earlier I showed it is a three-dimensional Dirac delta function. Okay. I think it will come with a 2 pi q factor, right? 2 pi whole cube delta 3 p minus. Okay. So what will happen is that this 2 pi q factor will cancel with 2 pi, this is 6, leaving you with 1 by 2 pi cube. And you will be left with delta function here, delta 3 p prime minus p. Yeah. Okay. Just replace that part. Now you see, as I told you, the moment these three factors are same, okay, the corresponding energy also will be same. Okay. You can replace not only p prime by p in the integration when I am integrating over p prime, but e prime is also root over p prime square plus m square. So there also you will replace p prime by p, 3 vector p prime by 3 vector p, and resulting in identification of e prime with e. Is it clear? So I'll carry out this integral, p prime integral, and I identify this with this will become e square. Okay? M square alpha beta is equal to 1, 2 b star p alpha b. Now, so E and E prime are same, 3 vector p prime and p are same. So the entire 4 vector p prime and p are same. Okay, because you are imposing the mass shell condition. The moment I identify p means p 3 vector p prime with the 3 vector p, I'm identifying e prime also with e, and in the process the 4 vector p prime also becomes identified with p, because all the components are become equal. Okay, so this p beta earlier I had p prime, so I can write u alpha dagger p, u beta, your p, this thing is your this thing. Okay, and this I have earlier shown is nothing but your E by m delta alpha beta, right? So this E will cancel, this E will cancel with this square, leaving with just E here, and m will cancel with this, leaving just m here. So ultimately what you get d3p m by E delta alpha beta. So this will become, this also will reduce to one summation only, alpha equal to 1, 2 b star p alpha bp alpha. Okay, so or even shorter, I can write down this as alpha equal to 1, 2. I can bring the summation out, and I can write down integral d3p by 2 pi cube m by e mod p alpha mod square. Okay, this is almost like your non-relativistic result. Only new feature which pops up here is this factor of m by e. Okay, otherwise it is almost like these things. So I have shown you how these mathematical manipulations have to be done. So remember, always carry out the x integration, which will give you the delta function, by which you will identify 3 vector p prime with p, and this will also will extend to identification with e prime with e. Fourth component কি? All the components become identical. So the 4 vector p becomes equal to the 4 vector p prime. Zeroth component equal হওয়ার আগে তো বলছি না, p0 prime equal to p0 হচ্ছে, তারপরে বলছি দেখো 3টা কম্পোনেন্ট আগেই ইকুয়াল হয়েছে, এখন 0th কম্পোনেন্টও ইকুয়াল হয়ে যাচ্ছে, because I am invoking the Matrices condition. তোমাদের সায়ন নিশ্চয়ই বলেছে যে এই যে ইন্টিগ্রেশন মেশারটা d3p by 2 pi cube to omega লেখে by e লেখে, this can be written alternately as delta of p square minus m square, right? Theta of p naught, আর আরেকটা কি থাকে, আরেকটা থাকে বোধহয় থিটা অফ পি নট, আরেকটা কি একটা ফ্যাক্টর থাকে, যাই হোক আমাদের আছে নোটে একটা ফ্যাক্টর থাকে, যাই হোক ওটা দ্যাট নট ভেরি ইম্পর্টেন্ট. What is important is that this condition is always incorporated, Matrices condition. The p square minus m square, এটাকে যদি ভাঙো it is 4p. So this actually is p naught square minus p vector square minus m square, which is same as e square minus p vector square minus m square. So p vector square টা যখন সেম হয়ে গেল, মাস তো সেমই, so e also should be same. So all the components being identified, the entire p mu prime is identified with p mu. So this is the steps that you have to follow. Yes? Is it clear? Okay. Now this was as far as the 0th component, the probability density. এটা একটু চালানো যাবে? এইটা just বুঝলাম না। Something analogous to that, right? Okay. Now let me calculate the J0 is the time component of the forecurrent. Now I'll calculate the space component of the forecurrent, the usual current. So I'll calculate what? Ji. So I'll have psi bar gamma psi, let me write psi bar gamma I psi, right? Okay. By psi bar gamma I is nothing but this part will be psi dagger, psi plus dagger, gamma 0, gamma I, psi plus. Okay. So now, what is gamma 0? What was the representation? Gamma 0 representation was I minus 1 minus I. So I have gamma 0, gamma I, which I call it alpha I. I define it to be alpha I. So if I multiply, I'll get this thing with 0, sigma I, 0. Alpha I will be 0, sigma I 0. Okay. So this I will so now here you dagger let me insert it here alpha, this matrix alpha. Okay, alpha I. Here this alpha I matrix will be there. Right? So again I'll run the same type of calculation, except that there will be U alpha dagger, U alpha I, U beta will be there as a matrix. Okay. So you will get essentially this thing. Let me write down these answers. Essentially run through the same calculation, integrate over x, you will get a delta function. You identified with p prime, all the components. Okay. So wherever e prime appears, write e, wherever p prime appears, write p. Only thing is that u alpha dagger and u beta p, that will be sandwiched, they will sandwich some matrix alpha I. Earlier it was just identity, now it will be alpha I. Nothing else, no change. So I can just write down the same thing. Ultimately you will get d3p by 2 pi cube alpha beta m square e square b alpha p alpha star bp alpha p alpha beta and you will have left with u alpha dagger p alpha I u beta p. Okay. Earlier you see what happened, the alpha I was not there, just identity was there. So that gave me E by m delta alpha beta. and E by M cancels with one of the E by M here. We are left with M by E, and delta alpha beta ensured that this is alpha and this is also alpha, and there is a summation over only alpha was there. Now this is the only small change that you have made. Okay. So now we'll identify this alpha actually later with the velocity operator. That we'll do later. Now the next step is so I can remove up to this thing. So now to proceed with this thing, I need to derive some identity which is named after Gordon. This is called Gordon identity. Okay. So let me write down this thing as follows. Towards Gordon identity. You have to write it very carefully. Let me write 0 is equal to, I'll argue why I can write it like this. U bar alpha P A slash Q slash minus M plus P slash minus M A slash So P and Q are the pair of 4 momenta. Okay, pair of 4 momenta. Now, A is any 4 vector. AMU is any 4 vector. And PQ are a pair of 4 momenta. Okay. Why this is 0? You can see that Q slash minus M acting on this thing will be 0, Dirac equation. দুটো এক জোড়া 4 মোমেন্টাম না 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 নট ক্যানোনিক্যাল 4 মোমেন্টাম একটা পি আর একটা কিউ যেটা আগে পি পি প্রাইম লিখেছিলাম এখন কিউ লিখছি পি আর কিউ ওকে so you see this q slash minus m acting on this thing will be 0 Dirac equation and the bar also will be p slash minus acting from the right on u bar p will be 0. That also I told you last time. Both bar and unbarred are annihilated by p slash minus m, one from the left, another from the right. Okay. In fact, I think one of the exercises was to show that. দেখিয়েছো? হ্যাঁ? দেখিয়েছো? Very good. করে দিয়েছিলাম? Okay. Anyway, so you can make use of, so this identity is trivially satisfied, right? So now I can simplify it further. I can collect the m terms. So it will be minus 2m u bar alpha p a slash u beta q And because A slash is a matrix, you cannot take it out. Gamma mu mu. Right? A slash is a matrix. Gamma mu mu. So you cannot take it out. M is a number, so you can take it out. So there will be similar factors. U bar alpha P minus A slash M U beta Q. Another will be same thing. Minus M, A slash will be there, but M being a scalar number will come out. So you will be finding U bar alpha P, A slash U beta Q. Okay. Next will be your U bar alpha P, A slash Q slash plus P slash A slash U B beta Q. Is it okay? So this identity holds. Now what I do, so I have basically this identity equal to 0. So now differentiate with respect to A nu say, both sides, or A mu, whatever. Okay? Mind that A slash is occurring here, just to, these are linear in A. So differentiation means you have to identify the coefficient of A nu or mu. Let me write mu. It's easier. So if I just do it, we will have A mu. Let me write A mu down, then it will be minus 2m U bar alpha P gamma mu. A mu gamma mu will give you A slash U beta Q plus U bar alpha P, and you have gamma mu Q slash plus P slash gamma mu Q beta Q. Okay. So now what it will be? This part, so I can take, since the coefficients A mu's are arbitrary, okay, I can identify this part to be 0. Okay. So let me erase this part, okay. I have to make some space. So I can write, let me write this part, U bar alpha P gamma mu Q slash plus P slash gamma mu U beta Q is equal to 2m U bar alpha P gamma mu U beta Q. Okay. দরকার পড়েনি হ্যাঁ মানে অ্যাবসলিউট কোএফিশিয়েন্ট দিচ্ছি কিছু প্রশ্ন ডিফারেন্সিয়েট করার দরকার পড়ছে না Now this part, regarding this part, let's see, I can write gamma nu q nu, q slash is gamma nu q nu, no? And p slash is p nu gamma nu gamma mu. Okay. So now I can gamma nu I can symmetrize or anti-symmetrize. This part I can write down as half gamma nu plus gamma nu q nu plus the same thing half gamma nu plus gamma nu p nu. Okay. So this will give me twice eta mu nu. 2 will cancel. So it will give you eta mu nu q nu. Same thing will happen here. It will give me eta mu nu q nu plus p nu. Right? Regarding this, what is that? That is the sigma mu nu. Lorentz generated spinodal representation. I think there is a factor of I by 2, I think, no? Clear to mone ache? Means sigma mu nu is equal to I by 2 gamma nu. Right? So 2 by minus 2i sigma nu. Okay. Q nu p. This was actually, it should be gamma nu, so I should be very careful. Mu nu should be interchanged. Here it is symmetric, here it will be this way. Because it is nu mu here. This part doesn't matter. This is symmetric. But this part you should be very careful. P nu multiplied by P nu. These are numbers. These are not matrices. Okay. So it doesn't matter. So this will give you 2i sigma mu nu minus 2i sigma mu nu. You take this side minus 2i sigma mu nu is gamma mu. Okay. And sigma mu nu is actually minus of mu nu if you interchange is antisymmetric. So this part will give you q nu and this part will give you minus p nu because interchanged. Okay. So this will give you p plus q mu. You raise the index by mu. Eta. এই আইডেন্টিটি ইউজ করছি। তো এইখানে আমি কি করছি, এইখানে যখন গামা মিউ লিখছি একটা সিমেট্রিক আর একটা অ্যান্টিসিমেট্রিক পার্ট, এইখানেও তাই করছি, কিন্তু রিমেম্বার এখানে মিউ নিউ আছে, এখানে নিউ মিউ আছে অপোজিট অর্ডারে। So I should be careful in the antisymmetric part. Symmetric part will not be affected. Extra minus sign. Okay. And minus 2i sigma mu nu or plus p minus q whole nu. টু কেটে যাবে, রাইট? প্লাস আই। Okay, so ultimately my this thing will be 2m u bar p. So I can write down Gordon identity as Gordon identity as u bar p now mu u beta q. Let me write q. This is equal to 1 by 2m 1 by 2m u bar alpha p p plus q mu plus I sigma mu p minus q mu. Okay, this is a Gordon identity. In the last term of special component of the current, you কি বুঝতে পারছি না। ঠিক আছে, আচ্ছা তাহলে আমাদের জেটা কি ছিল? জে প্লাস, তোমরা কি 1 ঘন্টার রেস্ট চাও? হ্যাঁ, আচ্ছা ঠিক আছে, তোমরা আসো তাহলে একটু তারপর কন্টিনিউ করছি। হ্যাঁ, কোনটা? হ্যাঁ হ্যাঁ লাগবে বলে এখন জিআইটাই ফাইনালি ইভালুয়েট করবো। হ্যাঁ হ্যাঁ তারপরে কন্টিনিউ করবো। হ্যাঁ 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 রাইট, ভালো লাগছে তো? ওয়ান ফর্ম যখন হয় তখন তোমার কি থাকে, ডিএক্স মিউ ডেল মিউ অফ এফ, ডিএফ ইজ ইকুয়াল টু ডিএক্স মিউ ডেল মিউ অফ এফ, তাই না? এখানে ডিএক্স মিউর জায়গায় গামা মিউ এসছে। হ্যাঁ হ্যাঁ, একটা লিঙ্ক আছে, মানে এখানেই থেমে থাকা যায় না, মানে আরো এগিয়ে যাওয়া যায়। তুমি যে হ্যাঁ হ্যাঁ হ্যাঁ, ওটা জিরো হচ্ছে, সুতরাং এখানে প্রোডাক্ট রুলটা একটু আলাদা। ডিএক্স নিউ ওয়েজ ডিএক্স নিউ প্লাস ডিএক্স নিউ ওয়েজ ডিএক্স নিউ করলে জিরো হচ্ছে, আর ওখানে গামা নিউ প্লাস গামা মিউ করলে টুয়াইস ইটা মিউ নিউ হচ্ছে, ওই প্রোডাক্ট রুলটা আলাদা। তো আন্ডারলাইন যে ভেক্টর স্পেস আছে 16 ডাইমেনশনাল ভেক্টর স্পেস, ওটা এক। 16 ডাইমেনশন মানে আইডেন্টিটি ডিএক্স মিউ 4 ডাইমেনশনাল, ডিএক্স মিউ ওয়েজ ডিএক্স নিউ 6 ডাইমেনশনাল, আবার ডিএক্স মিউ ওয়েজ ডি ল্যামডা সে আবার 4 ডাইমেনশনাল, ওয়ান ডাইমেনশনাল, তাহলে তোমার 16 ডাইমেনশন হলো। এনসিআর কারণ সবগুলো তো ডিস্টিংক্ট হতে হবে, তাই না? তো ডিএক্স মিউ ওয়েজ ডিএক্স নিউ মানে কি, মিউ মাস্ট বি ডিফারেন্ট, চারটার মধ্যে ডিস্টিংক্ট দুটো চুজ করো, 4C2 6। আবার যদি তোমার ডিএক্স মিউ ওয়েজ ডিএক্স ল্যামডা থাকে, চারটার মধ্যে তিনটা ডিস্টিংক্ট চুজ করতে হবে, 4C3 which is 4 হ্যাঁ, মানে এখানে 4 কম্পোনেন্ট স্পিনারের উপরে অ্যাক্ট করছে, সুতরাং গামা মিউজ গুলো ওই স্পিনারের বিভিন্ন উপর নিচ কম্পোনেন্ট, মানে ম্যাট্রিক্স আছে। হ্যাঁ, মিক্সিং হয়ে যাচ্ছে, আর হ্যাঁ পিমিউটা ই টু দি পাওয়ার মাইনাস আই কে ডট এক্স যে আছে ওটার উপর অ্যাক্ট করছে, ফাংশন যেটা আছে, যেটা ফাংশন ওটার উপর অ্যাক্ট করছে, স্পেস অ্যাক্ট করছে, গামা মিউটা এখানে অ্যাক্ট করছে। হ্যাঁ 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 হ্যাঁ, তো তোমার ভেক্টর স্পেস যার উপরে অ্যাক্ট করছে ইজ এ টেন্সর প্রোডাক্ট। একটা হচ্ছে গিভেন বাই এ কলম 4 কলম ভেক্টর, আরেকটা হচ্ছে স্কোয়ার ইন্টিগ্রাল ফাংশন বলতে পারো, প্লেন ওয়েভ যেটা তার উপরে অ্যাক্ট করছে, এটা টেন্সর প্রোডাক্ট ফর্মে আছে। টেন্সর প্রোডাক্ট তো শিখেইছো ডিফারেন্সিয়াল জিওমেট্রি। একটা হচ্ছে এনার্জি আইগেন স্টেটসে, একটা পজিটিভ ল্যামডা প্লাসটা হচ্ছে পজিটিভ এনার্জি আইগেন স্টেটস আর ল্যামডা মাইনাস নেগেটিভ এনার্জি আইগেন স্টেটস। আর পিএন যেটা ওটা হচ্ছে স্পিনের উপরে, মানে পি প্লাস এন যেটা, হ্যাঁ, এটা পজিটিভ এনার্জি স্পিন আপ স্টেট এবং নেগেটিভ এনার্জি স্পিন ডাউন স্টেটের প্রজেক্টর। আর অন্যটা হচ্ছে পজিটিভ এনার্জি স্পিন ডাউন, নেগেটিভ এনার্জি স্পিন আপ প্রজেক্টর। দুটোর ওভারল্যাপ নিয়ে আমার টোটাল প্রজেক্ট করতে হবে। হ্যাঁ হ্যাঁ হ্যাঁ, গুণ করে করবো। আমি যদি পি ধরো পি এন প্লাস করলাম, তখন ওটা আমাকে পজিটিভ এনার্জি স্পিন আপ সলিউশন দেবে আর নেগেটিভ এনার্জি স্পিন ডাউন দেবে। ঠিক আছে, এখন যখন আবার ল্যামডা প্লাস কে করব, ওই দুটোর মধ্যে আবার ওটাকেই চুজ করবে, ওটা পজিটিভ এনার্জি স্পিন আপ কে। ঠিক এরকম যে কোনো একটাকে আমি যদি চুজ করি, চারটা পসিবল স্টেট আছে, পজিটিভ এনার্জি স্পিন আপ ডাউন, নেগেটিভ এনার্জি স্পিন আপ ডাউন। যে কোনো একটাকে যদি চুজ করি, আমি এরকম দুটো প্রজেক্টরকে পরপর মাল্টিপ্লাই করলেই আমার কাজ হয়ে যাবে, একদম ইউনিকলি প্রজেক্ট করে দেবো। ঠিক আছে, ওকে। So let me come to the expression of J now. যেটা আমরা পেয়েছিলাম সেটা হচ্ছে J plus was d3p 2 pi cube m square by e square alpha beta b p alpha star b p beta u u alpha dagger p alpha dagger u beta p ছিল। Okay, this was my expression of this thing. So now I make use of the Gaussian decomposition. Gaussian decomposition মানে এটা গামা আই মিউ ইকুয়াল টু আই বসালে এটা ড্যাগার গামা জিরো গামা আই যেটা আলফা আই চলে আসবে। হ্যাঁ, so I have to consider mu equal to I, the special part. And P আর Q are এখানে different ছিল for general case, but এখানে P and both are P's. So this part will not contribute. Only this part will contribute. সুতরাং এটা হয়ে যাবে d3p by 2 pi cube m square by e square alpha beta b star p alpha b p beta, and you will have 2p mu, that means p mu by m. Q and p are same, there will be 2 p mu, 2 will cancel, so I can take that out, p mu by m. And in fact, it will be mu equal to I now. So I'm writing for general vector, so it will be p vector. And you will have E bar, U bar, আমি জেনারেল 3 কম্পোনেন্টই লিখছি না, জাস্ট একবারে করে দিলাম কাট শর্ট। হ্যাঁ হ্যাঁ, প্রত্যেকটা কম্পোনেন্ট ওয়াইজ ভ্যালিড হবে না। সুতরাং এখানে কি দাঁড়াবে, এখানে
স্যার এই স্টেপটা আগে
হ্যাঁ বুঝলাম না,
লাস্ট
কি বুঝলাম না, কি বলছে? হ্যাঁ হ্যাঁ, ভয়েস ব্রেক হচ্ছে। হ্যাঁ, এগুলো প্রবলেম, তোমরা এখানে এসে ক্লাস না করলে তো সম্ভব না।
না স্যার লাস্ট
আমি কিছুই বুঝতে পারছি না। তুমি কি করে, আমি কি করে বুঝবো? আমি এইসব পারি না। হ্যাঁ, আচ্ছা চ্যাট বক্সে লিখে দাও, তাহলে বলে দেবে। চ্যাট বক্সে লিখছে, কি বলছে দেখো।
স্যার লাস্ট লাইনটা আরেকবার বলতে বলছে।
আমি কিছুই হ্যাঁ আমি এটা করছি, তো আমি যদি এইটা করি, মানে এখানে মানে যদি গামা আই করি, হ্যাঁ, তো এখানে গামা আই আছে আর এখানে ইউ ড্যাগার করলাম, ইউ ড্যাগার গামা 0 গামা আই, আইএস কম্পোনেন্টে নিলাম, ওটাকেই বলছি আলফা আই। হ্যাঁ, আর এইখানে আইএস কম্পোনেন্ট নিলাম, এইখানে পি প্লাস কিউ, মানে এখানে মিউটা ইয়ে ছিল, আই ছিল, আই নিউ এরকম থাকছে। তো আমার কি দাঁড়াচ্ছে, আমার দাঁড়াচ্ছে এখানে পি আর দুটোই পি আর কিউ সমান, তো দিস টার্ম উইল নট কন্ট্রিবিউট। তো আমার দাঁড়াচ্ছে এখানে সিম্পলিফাই হয়ে যাচ্ছে, যদি আমার পি আর কিউ সমান হয়, তাহলে দাঁড়াচ্ছে 2pi pi বাই m, 2pi বাই 2m, মানে p বাই m, u bar alpha p u beta q. Now this is basically your delta alpha beta, তাই না? তো ইউ না, ইউ বার না, তো এখানে তো ইউ ড্যাগার আছে। আমি এইখানটা ড্যাগার করলাম, আর এখানে আলফা আই, দিস ইজ ইকুয়াল টু, হ্যাঁ এইটা ঠিক আছে। আমি এখানে আমার আছে মানে ইউ আলফা ড্যাগার আলফা আই ইউ বিটা, এইটা যখন পি আর কিউ সমান হলো তখন, হ্যাঁ না না, আমি তো জাস্ট আইএফ কম্পোনেন্টের জন্য লিখছি না। আমার কি ছিল এখানে গর্ডন আইডেন্টিটি, লেট মি রাইট দ্য গর্ডন আইডেন্টিটি। ইউ আলফা বার গর্ডন আইডেন্টিটি কি ছিল? হ্যাঁ, ইউ বার alpha p gamma mu q beta q. Oh, sorry, this was this. Okay, আমি যদি mu equal to I বসাই, হ্যাঁ হ্যাঁ, সে তো মানে তোমার এই না এইটা যখন লিখে দিয়েছি এইটা, হ্যাঁ এইখানে সরি এইখানেও বার হবে, এটাই তো আমি ডিরাইভ করেছি না, ইউ বার আলফা, এটাই তো ডিরাইভ করেছি। ইজ ওকে, ইট শুড বি ইউ বার। হ্যাঁ, so now let me simplify for q is equal to p, so এটা কি হচ্ছে, u bar alpha p gamma mu u beta p is equal to 1 by 2m u bar alpha p 2p 2, মানে এখানে ছিল এটা u bar alpha p mu ছিল, mu আমি এক্সট্রা পিছনে যাচ্ছি, দ্যাটস অল, রাইট? 2p mu u beta q. Okay, so this is nothing but 2 cancels, p mu by m u bar alpha p, আর কিউটা হচ্ছে p হয়ে গেছে, u bar alpha p u beta p. Now this is nothing but your p mu by m delta alpha beta. Is that it? আমি এখন এইটা এখানে বসাচ্ছি, যে আলফাতে আমার আমি স্টেপ জাম্প করেছিলাম, লেট মি গো। হ্যাঁ, আমি লেট মি গো ব্যাক, তুমি ধরো এটাকে লিখতে পারো ইউ বার গামা ভেক্টর, তাই না? বারটা ড্যাগার না, বারের মধ্যে একটা গামা জিরো আছে, ইউ বার মানে ইউ ড্যাগার গামা জিরো, গামা জিরো আলফা ইজ এগেন গামা আই, ঠিক না? তো তোমার এখানে যদি গামা 3 ভেক্টর করো তাহলে কি দাঁড়াবে, এখানে দাঁড়াবে পি বাই এম, 3 ভেক্টর পি বাই এম, এইখানটায় তুমি একটা 3 ভেক্টর পি বাই এমটাই লিখেছি, আর ডেল্টা আলফা বিটা আসছে ওখানটায়, হুম, ডেল্টা আলফা বিটা। Okay, so what you have is the following. P by m একটা ই ফ্যাক্টর কোথায় গেল, m by e, আচ্ছা m by e একটা m কাটবে, সুতরাং I can write down this as d3p by 2 pi cube m by e, this is a Lorentz invariant measure, আরেকটা ই আমি p এর নিচে রাখবো, এটা তো তোমার সাম ওভার খালি আলফা হয়ে গেল, equal to 1 to b p alpha mod square p by m, ঠিক না? p একটা ই নিচে রাখলাম, p by e, p by e, আরেকটা m by e এখানে রাখলাম, এটা লরেন্জ ইনভেরিয়েন্ট মেশার, এটাতে হাত দিচ্ছি না। ওকে, তো p by e তেই তো হচ্ছে তোমার গামা m v by গামা m ভেলোসিটি আসছে, তখন দেখতে পাচ্ছ যে জেতে যে আলফা ই আসছিল, আলফা ই এর জায়গায় you are getting v. So alpha can be identified as a velocity operator. Okay, so this is just like, and this is nothing but your p by e, so it is the expectation value of p by e. বিকজ এই পার্টটা তো ছিল তোমার প্রবাবিলিটি ডেন্সিটির মধ্যেও না, এটাকে এটা ছাড়া দিস আপন ইন্টিগ্রেশন গিভস ইউ দ্য রো জে নট, তাকে ইন্টিগ্রেট করলে 1 হচ্ছিল। So this part is like a probability density. এই পার্টটা বিপি আলফা মড স্কয়ার আলফা ইকুয়াল টু 1 to 2, এটা হচ্ছে ইনভেরিয়েন্ট মেশার, ঠিক আছে? The probability density into this thing so gives the average value of p by m, and this is nothing but your group velocity. Okay. So this part is just like a non-relativistic theory, and reproduces non-relativistic quantum mechanics. তোমরা হয়তো বলবে everything is nice, but there is a problem. Problem is that I have superposed only the positive energy solutions. Negative energy I have artificially ignored, and I got a success. So you may say that I have cheated. So kichi, right? So I should consider negative energy solution also, ideally speaking. Ki bolo tumra? Okay. And once I do that, I'll show that there is inconsistency will crop up. And this inconsistency will show that this one particle description of relativistic quantum mechanics is actually not adequate. You have to go to field theory. So this is yet another motivation for introducing field theory. Second quantization, this is the first quantization. And then eventually when I do field theory, this size, these so-called wave functions will become fields, quantum fields. Okay, that will come later. না, এটা তো তোমার জাস্ট তোমার নন রিলেটিভিস্টিকে যেটা হয়, নন রিলেটিভিস্টিকে কি হয়, psi star x psi x gives you the probability density, and তুমি এটাকে যখন তুমি মোমেন্টাম স্পেসে করো সিমিলার জিনিস আসে, psi tilde p this gives the probability density in momentum space. তার যখন তুমি p করো, ধরো ওয়ান ডাইমেনশনালি করছি p, হ্যাঁ, তারপরে ইন্টিগ্রেশন ওভার dp করো, this gives the expectation value of p, right? Probability density times this thing. So এখানেও probability density is this thing. হ্যাঁ, মানে এটা তো টোটাল সিস্টেমটাকে ইন্টিগ্রেট করা আছে না, আমি ইন্টিগ্রেশন ওভার ডিএক্স করেছি টু দ্য এক্সটেন্ট দ্য ওয়েভ ফাংশন ইজ মিন্স কি বলবো এক্সটেন্ডেড, দ্য হোল এক্সটেনশন অফ ওয়েভ ফাংশন হ্যাজ বিন, হোল সিস্টেমের জন্য আমি একটা এই ভেলোসিটি পেলাম, হোল সিস্টেমের জন্য, দ্য হোল প্যাকেটের ভেলোসিটি, that's called group velocity. Okay. Now let us consider time evolution of a Gaussian packet. Gaussian packet at t equal to 0 given by psi this is equal to Gaussian packet so d is the spread of the wave function. Hello. d is the spread of the wave function. Gaussian wave function তো এরকম থাকে না, এই যেটা d হয়. Okay, so it is a Gaussian wave packet. d is the spread of the wave function, and w, you can take it to be a spinor of the form taken to be a spinor of form y 0. Okay. Now, let me write down the full expansion of the wave function. That means including the negative energy part also. All possible combination. So, okay. Earlier, I just superposed only the positive energy part. Now, I will consider the negative energy part also. ঠিক আছে? It is হচ্ছে profile of the wave function in x space. আর w যেটা এটাতে বললাম, it is something like phi 0. Phi হচ্ছে একটা 2 component spinor আর 0টা হচ্ছে আরেকটা 0 0 টোটাল 4 component. উপরেরটাকে phi বলছি আর নিচেরটাকে 0 বলছি। ওকে, তো আমি এখন কি করব, psi of tx তাকে আমি full expand করব। Full মানে I'll take both negative energy as well as positive energy. So I'll take d3p by 2 pi cube m by e. হ্যাঁ, না না আমি দেখো আমি আসছি এক মিনিট, লেট মি রাইট ইট ডাউন, আমি বলছি summation over alpha bp alpha a general packet will be of this form, consisting, this is the negative energy part, This is the positive energy part, যেটা আমরা আগে consider করেছি so far. Okay. So now, my question is, I will identify, so at t equal to 0, what it will be? At t equal to 0, you have to just this thing. At t equal to 0, psi t is equal to 0, x will be just d3p by 2 pi cube m by e alpha equal to 1 to bp alpha u alpha p e to the power I 3 vector dot x plus d star v alpha p e to the power minus I p dot x. So just expanded p dot x key p dot x to et minus p dot x. है ना? I just substitute t equal to 0 te, it will be just I p dot x, আর ওখানে এটা opposite minus I p dot x. এখন এই psi-টি এটা হলো general expansion of a packet taking into account both the contribution of positive and negative frequency solutions. Okay? Huh? D star, I mean, for future convenience, in anticipation I'm writing. I can write it, this will be complex number in general. I just write in anticipation. It's a good question. I'm writing, I could have written, there's no, at least you cannot object it legally. So I can write any number as D star. Okay. Now, I'm saying that even this solution should be expanded like this, and I should be able to identify what are the corresponding coefficients b and d for this solution if I identify this with this. Okay. Now, কি করে করব? Just use these orthonormality properties. That you will do it. So, no, you have to carry out the inverse transformation, so to say. Fourier transform যখন করি, quantum non-relativistic quantum mechanics কি করো? I wrote earlier that you write psi x is equal to dp e to the power ipx ap say. You can write the inverse transformation. AP is equal to inverse Fourier transform. And why you are able to calculate the inverse Fourier transform? Because this plane waves forms an orthonormal basis. তাই না? তো তুমি ওটাকে ইয়ে করছো, you are basically what you are doing. Non-relativistic quantum mechanics, just you have an abstract state psi, and you have position overlap. This cat x, they form an orthonormal basis, Dirac delta orthonormalization, right? And you have cat x, bra x, integration dx. This gives you resolution of identity, right? Similarly, in the momentum space, dp, cat p, bra p. Okay. So what you are doing here? You say that, okay, I will insert momentum eigenstates, momentum resolution, say dp, cat x, p, psi p, right? And px is nothing but dp e to the power I px by root 2 pi or whatever. and then you have psi, you call it psi tilde p, function of x. And this you call is psi of x. So psi of x you can write with the momentum. So this px or its complex conjugate are, so complex conjugate will be px, it will be e to the power minus ipx by root 2 pi. Right? So you employ it to, just like you got from psi x the psi p you written in terms of psi p, likewise you can, instead of inserting the completeness relation for p, you can start from here and use the completeness relation for x, you can go the opposite way. And that's what is the inverse Fourier transformation is all about. Right? So what you are making use of, that they are orthonormal. Likewise, p also is like this. P prime p is equal to delta p prime minus p. Okay. So they are delta function orthonormal and satisfy completeness relation. Is it okay? So you are making use of this to obtain one expression from the other. So the wave function, you can say that is a position representation because you are taking overlap with the position basis. The same abstract state, when you take overlap with the momentum basis, you get the momentum representation. The abstract state is same. You follow? It is going from one basis to another basis. Both coordinates of momentum can be used as basis. They are alternative choice. You can have many other choices, infinite number of them. But these are standard choices. Okay. So likewise, you can do here also. The coefficients, BP alpha is something like analogous of psi tilde p, which earlier I wrote down in the beginning of the class as AP. Right? They are analogous of this. Here extra only polarization index is coming. The momentum, for momentum P, the polarization alpha. If it occurs with U, means that because B always occurs with U, so it is a positive energy polarization index alpha. Okay. And means alpha will be 1 or 2, means it will be actually, it occurs with BP alpha, so B occurs with U, so it is a positive energy. Positive energy alpha can be 1 or 2 spin up or spin down. Here, it will be negative energy spin up or down. Okay. So you can invert it. So now you, once you equate it, and you can, all that you have to do, make use of the, write it here. So I give you as an exercise. The inverse, you know, the Fourier transform for Gaussian is Gaussian itself. Isn't it? You know that, right? Huh? And this formula is this d3x e to the power 2d square minus I p dot x. These are all three-dimensional, okay? This is equal to 2 pi d square p by 2 e to the power okay. Make use of this to show that this identity to show that W by pi d square 3 by 4 Okay. Now, you have to write d3x, just a minute, this. So what I am doing, I have the form of psi 0x both sides. So I am taking Fourier transform, special Fourier transform of both sides. Okay. The right hand side I have the plane solutions. So I have to take Fourier transform of that. So once I do that, I can write d3x d3p prime by 2 pi cube m by e prime alpha b p prime alpha u alpha p prime e to the power I p prime dot x minus p dot x plus b star p prime alpha v alpha p prime e to the power minus I p plus p prime dot x. That's what you will get. This is a simple thing. Just take, multiply by e to the power minus p dot x, and this factor is already there. Means multiply by this thing and integrate over d3x for this plane wave solution at time t equal to 0. So energy exponent will not come. Only the 3 momentum p and p prime will come. Okay. So if you just show this thing, and once you do that, the rest of the work is simple. d3x, if you just integrate, you will get p delta of p prime minus p from here. Okay, and here you will get p prime plus p, delta 3 p prime plus p. You carry out the integration over x. Is it clear to you? আমি তো ইকুয়েট করছি না, প্লেন ওয়েভ এক্সপানশন জেনারেল ফর্মটা লিখলাম। জেনারেল ফর্ম লিখে আমার I've identified that is equal to a psi at tx ছিল, t এর জায়গায় 0 বসালাম। Now I am trying to evaluate the coefficients. That's my ultimate aim. Right. ইনভার্স করব। তো দেখো, ইনফ্যাক্ট t equal to 0 বসিয়ে দিলে you do not have any energy exponent. সব 3 ভেক্টরে ট্রান্সফর্ম হয়ে গেল। তারপরে যখন এটা মাল্টিপ্লাই করলাম, এখানে e to the power minus I p dot x ছিল, এখানে আর এখানে তো নেগেটিভ এনার্জি ছিল, একটা সাইন এটার অপোজিট ছিলই, আর এখানে আবার অপোজিট হয়ে গেল e to the power minus I p dot x. The 3 momentumটা এখানে, this will after integration over d3x will give you delta 3 p prime plus p, আর এখানে দেবে delta 3 p prime minus p. Is it okay? Just simple, you multiply both sides, আর w টা একটা কনস্ট্যান্ট স্পিনার নিয়েছো, উপরের দুটো কম্পোনেন্ট সার্ভাইভ করছে, জিরোটা নিচে, ওটাকে বাইরে বের করে দাও, that doesn't have any x dependence. Okay, uk vk যখন লিখি তো k ডিপেন্ডেন্স থাকে, x ডিপেন্ডেন্স থাকে না, x মানে তো ফেজে থাকে e টু দি পাওয়ার মাইনাস i k ডট, তারপর যখন তুমি সুপারপোজ করো উইথ রেসপেক্ট টু p, কোথাও আর x ডিপেন্ডেন্স আসে না, x ডিপেন্ডেন্স এক্সপোনেন্টে থাকে। So everything else you can take that out. এটা আমি করেছি, w টাকে করেছি, আর এখানে তো এটা দিয়ে মাল্টিপ্লাই করেছি। করে ইউ হ্যাভ টু মেক ইউজ অফ দিস ফর্মুলা ইভেনচুয়ালি। যাই হোক, এই স্টেজে তোমার এটা হচ্ছে, তো এটা কি দাঁড়ালো, এটাকে যখন তুমি করলে পি প্রাইম মাইনাস পি, থ্রি মোমেন্টাম দুটো এক হয়ে গেল, আর এখানের থ্রি মোমেন্টাম দুটো অপোজিট হয়ে গেল, ডেল্টা 3 পি প্রাইম প্লাস পি। আলটিমেটলি যেটা দাঁড়াবে, দিস উইল গো ডাউন। আমি তোমাদের বলছি, মানে ইন্টারমিডিয়েট এক দুটো স্টেপ দিলাম, ফাইনাল স্টেপটা দিচ্ছি। m by e alpha bp alpha এখানে পি টিল্ডে আসবে, পি টিল্ডে হচ্ছে 4 ভেক্টর পির মতনই, পি মিউটা যদি থাকে p0 আর p ভেক্টর, তো পি টিল্ডে মিউটা হচ্ছে p0 মাইনাস p ভেক্টর, এখান থেকে আসছে। তারপরে এটার জাস্ট আইডেন্টিটিটা বসাও, বসালে পরে আলটিমেটলি শো ওকে, আপ টু দিস ইজ স্ট্রেট ফরওয়ার্ড। ঠিক আছে, তারপরের স্টেপে তুমি মেক ইউজ অফ অর্থোগোনালিটি রিলেশন। ইউ আলফা ড্যাগার দিয়ে যদি করো, তো ইউ আলফা ড্যাগার ডাব্লিউ আসবে, আর ইউ আলফা ড্যাগার এখানে ডেল্টা ফাংশন দেবে, ক্রোনাকার ডেল্টা। আর ইউ আলফা ড্যাগার মনে আছে ভি এর সঙ্গে অর্থোগোনাল হয়, the three momentum flipped, that will be used here. Okay, so you show Okay. So, okay, I'll continue after lunch. ঠিক আছে? তোমরা যদি কিছু কোশ্চেন থাকে আসতে পারো। এটা সুমিত, এটা কি করে দাও। Okay, onliners, you can disconnect now. If you have any question, you can ask us. 2:30. So, please derive this thing. I've given you some of the intermediate steps. So, once you know these coefficients, you know the form of the wave packet at later time t. Okay. Now let me see what these objects are. These two objects. Okay. Again, it is a you see we had u alpha k was this thing, no? This was my u alpha k, right? And phi 1 m0, remember alpha is equal to 1 and 2. Phi 1 m0 was phi by itself a two component spinner. Phi 1 m0 was 1 0 and phi 2 m0 was 0 1, right? So, and here sigma dot k is a 2 by 2 matrix. It will act on this two component object here. Okay. So, if you just calculate it, just expand this thing, you will get this object. This is a simple verification. This is a 4 component spinner. You will get okay. Root over e plus m by 2m is 0, k3 and this. If you just multiply it, 1 0, that will get this. Sigma dot k will be sigma 3 k3. Along the diagonal will be k3 minus k3 because sigma 3 is 1 minus 1 along the diagonal. So you can easily see that it will be acting on phi 1, it will give you K3, and the other component likewise you can get like this. Okay. So it's a simple exercise. Likewise, you can calculate V also. I'm just writing V this is U, this is actually, I have calculated U1 of K, U1 of K. Okay. V means for 1. So I have taken phi 1 to be 1, 0. I have substituted 1, 0, and I've got this V1 of K. Okay. For V1 of K, similarly, you can do V1 of K, K3, K1 plus I K2, sigma dot K আছে না এখানে তো sigma is Pauli matrices, K3 sigma 3 plus K1 sigma 1 plus K2 sigma 2. So sigma 1 sigma 2 গুলো অফ ডায়াগোনাল, যদি K1 plus I K2 এই ফর্মে আসবে, আর sigma 3 জন্য এটা ডায়াগোনাল, K3 minus K3 along the diagonal. তো ওটা যখন এটাতে অ্যাক্ট করবে তখন K3 দেবে, আর বাকিগুলো যখন অ্যাক্ট করবে তখন তোমার K1 plus I K2 নিচে আছে, ফার্স্ট রো সেকেন্ড কলম, সেকেন্ড রো ফার্স্ট কলম। হ্যাঁ হ্যাঁ হ্যাঁ, প্রথম কলমের ভ্যালুগুলো দেবে না, এটার উপর অ্যাক্ট করলে। ওকে, তো V3 কে রুট ওভার 2m E plus m, এখানে আসবে K1 plus I K2 2m E plus m. V1 কেটা এই দাঁড়াবে, জাস্ট যা এক্সপ্রেশন আগে দেওয়া ছিল ওটাকে সিমিলার ওয়েতে যদি করো। ওকে, নাও আই ওয়ান্ট দিস U alpha dagger P, K এর জায়গায় P and K are basically same because P equal to H bar K, H cross K, right? The H bar is I've taken to be 1, so they're basically same, so don't bother. So you just calculate this. So the moment you take dagger, it will become a row matrix, right? These being real entries, they will be up to this, they will be unaffected, but for this it will be complex conjugate of that row matrix with these things. So it is a, then you multiply by W on the right. W is a column matrix, column spinner. Top two components are surviving, say phi 1, phi 2. So you can write down here U alpha P W is equal to dagger is E plus m by 2m 0 K3 K1 minus I K2 this U dagger W was what? W I have taken to be phi 0, so I can write it as phi 1 phi 2, 0, 0. Right? So you just multiply. So what you get? This 0, 0. So these two components will not contribute. These also will not contribute. Only phi 1 will contribute. So you'll get root over e plus m by 2m phi 1. Okay. Likewise, if you calculate V1 dagger k, sorry, U1, I'm calculating for first polarization, alpha equal to 1. Okay. Alpha equal to. So if you likewise calculate V1 dagger k, so these calculations also I leave as an homework. Okay. So this you will get K3 phi 1 plus K1 minus I K2 phi 2 by root over 2m e plus m. Okay. So this is this thing. Now you can, these are numbers B and D stars, right? They are the coefficients. So these coefficients I cannot compare, find the ratios. And when I calculate the ratios, these factors are common. So only this ratio between these and these will come, right? So I can write B P1 alpha equal to 1 divided by D star P alpha equal to 1 is equal to U1 dagger K. K or P I just writing same way, dagger W divided by V1 dagger KW. Okay, and this I have calculated. This is equal to root over e plus m by 2m phi 1 divided by this thing K3 phi 1 plus K1 minus I K2 phi 2 divided by root over 2m e plus m. Okay. So if I compare the ratios, it is like this. So you see, it will jump, so you can so now this you can see that this is root over e plus m by 2m phi 1 into this will jump, so this will have root over 2m e plus m by K3 phi 1 plus K1 minus I K2 phi 2. Okay. So this 2m will cancel, and then you will have e plus m phi 1 divided by, you will get this thing this you can write down. Okay, you can just write for the time being k1 minus ik2 phi 2. Okay, so this is as if you are having the, roughly speaking, if you consider, say, particle moving in the third direction, the only k3 component will survive. Then you will have roughly E plus m by k3, means magnitude of k, which is a k3. Okay, approximately like you will get this. Okay, so or I can write rather opposite way. Just take
Sir,
the reciprocal. So equivalently,
sir,
huh,
phi 1 is 10 and phi 2 is 01, right?
huh,
Phi 1 is 10
and phi
and
2 is
phi 2 is
0,
01.
yeah,
Okay. So when K3 is 0, I mean the particle is not moving in the Z direction,
huh.
then this equation, from this equation, I am getting E plus M times phi 1 divided by K1 minus IK2 times phi 2.
Yeah, that's why I've written tilde. This is the approximation I'm doing. Okay, see, this is of the order of that. This is of the order of that.
Okay. But how could we just divide two column matrices? I mean phi 1 by phi 2.
No, no, phi 1 and phi 2 are not matrices. Phi 1 is some number, phi 1, 0. Phi itself I have taken with W. I have taken, no, W I have taken phi, this thing, and phi by itself is phi 1, phi 2. And 0 is 0, 0. So these are numbers.
Oh, okay.
So this just to indicate that there's an order on that. Okay. So you see the D star, this thing is the order of k magnitude divided by E plus m. Generally, in the non-relativistic situation, when the particle is moving very slowly compared to the speed of light, the magnitude of the linear momentum, 3 linear momentum, will be very small compared to the rest mass of the particle. That you understand, right? Magnitude of the 3 momentum will be very, very less than rest mass of the particle. So this will be almost 0 kind of thing. So D by B, D is the coefficient of the negative energy part. This will be negligibly small compared to the positive frequency. The positive frequency part will dominate. Huh? Non-relativistic limit. In the non-relativistic limit, linear momentum is very, very small compared to the rest mass of the particle. Rest mass is huge. Okay. So you can ignore in this situation this negative energy part. So that's why in non-relativistic quantum mechanics, we can safely ignore the negative energy part. But this becomes matter of concern if you want to do relativistic physics. Then you have to take those things very seriously. If the particularly particles moving at a speed which is considerably closer to the speed of light. Okay. There's another thing. Thus, I had introduced the spread of the wave packet given by D. Right? Now there are another length scale that is involved here because the particles have mass m. So there is an associated Compton wavelength. and contour wavelength is given by h bar by mc in general case. But we are working in the unit of h bar and c to be 1. So it is just 1 by m. So mass has inverse length dimension in the unit h bar equal to c equal to 1. That you can check for inverse length. Okay. So this automatically gives you a length scale. Now there will be competition between these length scale. One between the spread of the wave packet d, Gaussian wave packet I wrote the spread d, and this contour wavelength. Huh? Contour wavelength gives a natural length scale of the problem. Na? Particular যখনই mass m হবে তখনই এই length scale টা চলে আসবে. It gives a natural length scale to your problem. ঠিক আছে? On the other hand, there is a spread of the wave packet d. This is another length scale. So there will be tension between these two scales. Okay. Now let us see in what happens when one is too big from the other. There are two extreme situations. So this is a length scale. So if your spread d very much length greater than the Compton wavelength, lambda c, 1 by m, then what happens? You see 1 by m much bigger than this thing. So this you can see that again it will correspond to basically the non-relativistic limit. Much greater than m. So 1 by m is very small. Compton wavelength is very small compared to the spread d. Okay, this is a spread d. And Compton wavelength will be very small, say lambda c. Very small. Huh? No. Spreaded D, that I had introduced, no? Gaussian wave packet D. The negative energy coefficient, huh? No. It is star ও আছে, এটা তো বুঝতেই পারছো। Distance এর তো real imaginary part হয় না। আর এখানে argument ও আছে k alpha, বুঝতেই পারছো। এটা that correspond to that D. There are two cases that I will consider. একবার এটা spread D এটা থেকে অনেক বড়, আরেকবার উল্টো হবে much less. কোনটাতে? এইটা এইখানে তো তোমার মানে ডিটা তো তুমি ইয়ে করা হয়েছে না, মানে এখানে ক্যালকুলেট করা হয়েছে, ক্যালকুলেট করে তোমার ডিটা এসেনশিয়ালি ক্যান্সেল আউট করে গেছে। না কিন্তু হ্যাঁ হ্যাঁ এক্সপ্লিসিটলি নেই। গুড কোয়েশ্চেন। মানে ওর বক্তব্য যে একটা স্কেল হাফিশ হয়ে গেছে রেশিওতে গিয়ে। হ্যাঁ 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 মানে দেখো এই যে মানে এটা ইমপ্লিসিটলি আছে ডিটা, এই যে কেটা This k you can roughly say is associated with this spread, roughly. Keta is 2 pi by lambda na. So roughly is, I mean, this is an order of magnitude estimation. Roughly you can say that this k contains information about this spread D. Because this spread D was in the position space. So that determined your position uncertainty of the order of D. So that in turn determined your momentum uncertainty. Momentum uncertainty will be given by inverse of that, 1 by D kind of thing. So you have a competition between these two length scale. Okay, this is implicitly present, explicitly not present. Is it okay? Means this will give you an uncertainty, delta x of the order of D. And delta P or K of the order of 1 by D. These are rough estimates. And this K you can take it to be some sort of value which will correspond to this D. Okay. So now you can see that if D is too large compared to the Compton wavelength, this coefficient, that means D will spread up, and means this K you can think of is 1 by D, this spread. If they spread up very much, again K will be very small compared to this thing, and you will see that this D, negative energy component, will be substantially small. So if your system wave packet has a spread which is much above your Compton wavelength, the contribution of negative energy solutions will be heavily suppressed. One by D. Dimension देखो. Okay. So in this case, what happens is that your one particle description that you have, so far I have been talking about one particle quantum mechanical system, right? This one particle description of relativistic quantum mechanics becomes incomplete. Okay. On the other hand, the other limit, when this sign is reversed, particle spread is comparable to 1 by m, something like this, of the order of the Compton wavelength, then this becomes quite large. So you cannot ignore it anymore. So these are indications that at the relativistic domain, the quantum mechanics as such of a single particle, or for that matter in a finite number of particles, description becomes incomplete. You have to go to field theory. There is no way out. Okay? What I am saying is that if you want to incorporate relativity into the theory, so far you have been doing non-relativistic quantum mechanics. But the moment you claim that, no, I want to do relativistic quantum mechanics by taking into account the relativistic effects, then you find single particle or two particle or n particle quantum mechanics descriptions become incomplete. Okay. Means you have to do quantum field theory where there is necessity of introducing multi-particle states. The concept of creation, annihilation of particle can only be described or accommodated in the field theoretical case while you carry out second quantization. Okay, not otherwise. না এখান থেকে আমি দেখাচ্ছি ইনকমপ্লিটনেস হয়ে যাচ্ছে নেগেটিভ এনার্জি সলিউশনস the moment you show that negative energy solutions become pronounced in certain domain, that means you cannot ignore negative energy solutions anymore. The moment negative energy solutions are not ignorable, that means your any particle will cascade down to negative energy states. So system becomes unstable, right? If you want to do quantum mechanics, you have to ensure that your system is bounded from below. The energy is bounded from below. If you have negative energy states, then it is not bounded from below. So with this logic, I am saying this. You cannot ignore negative energy states anymore if they come very close to Compton wavelengths. Okay. Huh? Uh-huh. Next, I leave 2 more homeworks for you. This is the normalization condition. Just check the way I did for the just positive energy case, then D was 0 and you had this, right? So this was as if you are the probability density, right? And now the probability density will change to this thing. That means there will be contribution from negative energy part also. Okay. So this as far as the J0 part is concerned. What about the special component? Special component will be These two exercises, please you do. This is straightforward. So you remember when D was absent, both these terms were absent. This term was absent. This term was absent, and then I could identify, because this is an invariant measure, this could give expectation value of P by E, which give me the group velocity. I0, sigma I0, V beta P, and here also sigma I0, U alpha, P tilde. P tilde is the 4 momentum with the 3 momentum reversed, the same notation I had used earlier. Okay. So, up to this, you see, this is just straightforward generalization, presence of D. But this is a bit surprising term. This was not anticipated. This is a cross term. And this represents very high frequency, 2IET. As the frequency is omega, means this represents omega is equal to what? 2m c square by h bar. If I restore all the h bar and c, this will represent, because this is 2m. So 2m, and this is just after restoration of the dimensional consideration, restoration of the fundamental constant by dimensional consideration. So these are the frequencies. So it shows that there's a huge frequency oscillation between positive and negative energy states. And there is no simple way to explain all this. And this feature, presence of this high frequency, is known as Zitterbuergang. এতটুকু পর্যন্ত তো ঠিক আছে, হ্যাঁ? You expect the straightforward generalization, presence of this thing. But এইখানে একটা দেখো e to the power is a phase আসছে, time dependent phase. That means this represents oscillations. And these oscillations are of the order of 2e. Okay. So it will be the corresponding frequency will be 2m c square by h bar. Can I mean h bar I have restored, reinstated this dimensional constant. I can work with this thing, c h bar equal to, just a minute. হ্যাঁ মহারাজ বলুন।
আমি 24, 28 দুটো ডেট দিয়েছিলাম।
হ্যাঁ 24 তো বোধহয় কনফার্ম করে দিয়েছে, রবীন্দ্রন কথা হলো, ও তো রিপ্লাই
তিনজন করে দিয়েছে, কিন্তু তিনজন বিদেশি করে দিয়েছে, কিন্তু ইন্ডিয়ান করে নাই কেন?
না করে দেবে, আমি ফোনে কথা বলেছিলাম, করে দেবে।
আমাদের সেখানে দেখলাম কেন উন্নত দেশ অনুন্নত দেশের তফাৎ দেখলাম।
সেই
কম কি ওরা কিন্তু
হ্যাঁ সেই
আমি বরাবর দেখেছি।
হ্যাঁ
ইন্ডিয়া রয়েছে, হ্যাঁ ঠিকই আছে, তো যাবো তো, তুমি মনে রাখলে আমি কি করবো, আমাকে জানাতে
সেই
আমাকে বলে আমি তো যাবো তো, কেন ভাবছেন কেন? আরে ভাবছি মানে সঙ্গে সঙ্গে।
হ্যাঁ না সে তো ঠিকই। হ্যাঁ হ্যাঁ আমি কথা বলেছি লাঞ্চের সময়, আজকে আমি আছি বেলুড়ে, আজ ক্লাস নিচ্ছিলাম। হ্যাঁ 24 হ্যাঁ 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 হ্যাঁ
আপনাকে থাকতে হবে।
ঠিক আছে ঠিক আছে। হ্যাঁ So it is a oscillation connecting between positive and negative energy solutions. B and D are both are present. So it is a coupling kind of thing. না ওইরকম না ব্যাপারটা মানে there is a coupling between positive and negative energy coefficients. Okay, and this coupling term depends on this object, which is nothing but a phase representing very high frequency. Okay. It is not possible to give proper interpretation of these things within the framework of quantum mechanics as such. This shows that quantum mechanics, relativistic quantum mechanics is inadequate. It is incomplete theory. হ্যাঁ মানে একটা তো তোমার ইয়ে হচ্ছে negative energy interpretation, not only interpretation, means I showed that if you take a Gaussian wave packet and the spread is reduced to less than of the order of less than 1 Compton wavelength, negative energy, this thing will be quite substantial coefficients. The presence of the negative energy solutions will be quite substantial. So you cannot ignore it. So your system has those energy levels, and at any moment it can cascade down from high energy to negative energy thing. There is no lower bound. So system becomes unstable. This is one way of saying it. But the presence of these frequencies is bit problematic. You see, even we don't know how to give a proper interpretation of these things. Okay. So we say that there are some interpretations, but means you have to take them with some pinch of salt. I will not go into the details of these things, but in any case, it is safe to say that this shows some incompleteness of the relativistic theory of Dirac, relativistic quantum mechanical formulation of Dirac, and this suggests that we should go beyond and give proper second quantized field theoretical interpretation of all this. Okay. So please work out this algebra. It is not a very big deal. ওই একই পদ্ধতি x ইন্টিগ্রেশনটা আগে করবে, মোমেন্টাম গুলো মিলিয়ে দেবে, তারপরে যেরকম ডেল্টা ফাংশন আসবে ওইভাবে করে যাবে। Okay. There is yet another thing that I want to discuss. This is called Klein paradox. You have done the very first few lectures of your quantum mechanics course, potential well problem and then potential barrier problem and things like that. I'll do the similar kind of thing here now with the Dirac equation. Okay. So a relativistic particle is approaching a potential barrier. And I take a plane wave solution is coming, I take it to z-axis, and the potential height is V. Okay, this is the energy. Potential height is V. So I take incident psi function of z. First of all, this e to the power I kz will come. This is just for the special part. I'm ignoring the time part. Special part, the stationary state wave function, so to say. Time part is ignored. So it is propagating along the z direction. That's why plus I kz. And multiplied by this thing u. I'm taking these particles to be positive energy particles, so it will contain both spin up and down, both the cases is possible. So I'm taking the spin up part. Okay, so alpha equal to 1 e plus m by 2m phi 1 m0 and sigma 3k 2m. Okay. I'm considering an incident wave particle of positive energy spin up approaching a potential barrier like this. Huh? Incident. Incident plane wave is approaching in the positive z direction. So its plane wave part will be this. U part is this. And since it is spin up, I'm considering phi 1. Phi 2 will be spin down. Okay? Particle. Potential barrier of height b. Height in the energy space. Okay. So if you just put phi 1 m0, phi 1 m0 is nothing but 1 0, right? So you will get this is equal to okay. The whole thing I can simplify further by, you see, these two entries are 0, so I can just multiply the whole thing, say root 1 by root 2m, I can just cancel, because overall factor I can just forget. Okay, and further I can multiply by 1 by this thing. So if you just multiply this thing by root 2m by e plus m. Just multiply. Okay. What do you get? I'm asking. Then you will get 1, 0, 2m will cancel anyway, and you will get k by e plus m 0 to the power I k z. So I can write down this thing up to an overall factor, because in my problem energy is constant. The incident particle has energy E, which is satisfy this relation E square minus k square equal to m square. So since k is fixed, E is also fixed. So up to an overall constant, I can take the incident wave function to be just like this. I just forget about those unwanted constant. Why do you want to retain them? Okay. So I'm not normalizing it the way I normalized the earlier one. So I don't bother. Once I take these to be the case, then I'll find out what is the reflected and transmitted part. There will be reflected part and there will be transmitted part. Okay. Let me write down what is the reflected part. So this is the region which is called z greater than 0, and this is the region I call it z less than 0. So it's approaching from the z less than 0 part, negative z axis, and proceeding towards the z positive part, and the barrier lies at x equal to 0. Okay. Now, the reflected wave has a form I can take this form as an such a e to the power minus I k z So what I have done, you see, for reflected part, I am taking, I don't know whether there will be spin flip or not, right? After reflection, I don't know. This is the first time I'm learning. So I have to keep my option open by putting this part also, which is the coefficient for reflected. Both the cases they are reflected. The difference is that this is positive energy spin up solution, and this is negative energy spin down solution. Okay, you know how to calculate, obtain them. I have discussed the polarization by projection operator, so you can easily construct it. Okay? Huh? কি করে পেলাম? I know that if k is the incident force momentum, then your reflected force momentum will be in this direction. It will be represented by minus k. So I flip the minus k sign, k to minus k. So here I had k, I replaced by minus k. Energy will not change as far as positive energy solutions is concerned. Okay. So this part gives you the wave function part, and this is the spinorial part. So both these are traveling in the minus z direction, and this is the negative energy, the spin down just a minute, spin down, no, sorry, it's positive energy. This is also positive energy. This is a spin down and this is a spin up. Okay, sorry, I made a mistake. এটা তো এই পার্টটা তো বুঝলে, এটা জাস্ট কেক সেকেন্ডের জন্য জাস্ট স্পিন ডাউন, তুমি যে প্রজেকশন অপারেটর আমি দিয়ে দিয়েছি, অ্যাপ্লাই দ্যাট, ইউ ক্যান ফাইন্ড আউট, you can apply the projection operator and see how it looks like. ঠিক আছে, basically not only projection operator, you just write phi 2 in this case, phi 2 0 1. Here I have taken 1 0, you take 0 1, that will give you this. Okay, and whatever sign, if you find there is something, you should ensure the relative signs are all right. Overall sign, whatever you dump in this coefficient, ওখানে ঢেলে দাও যা sign আছে, that you will determine anyway from the boundary condition. Okay, so reflected wave is this. Now come transmitted wave. So this is in z less than 0. This is also z, just like here this is z less than 0. So the transmitted wave has the form আচ্ছা মাইনাস কে হবে নাকি? স্পিন ডাউনের জন্য তুমি এখানে phi 2 নাও, minus 2, হ্যাঁ মাইনাস কে হবে নাকি? জাস্ট
সিগমা 3 কনস্ট্যান্ট
হ্যাঁ, কিছু কথা বোঝা যায় না তোমাদের।
বলছি সিগমা 3 নিচের কম্পোনেন্টে তো -1 আছে
কি? হ্যাঁ 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 হ্যাঁ, ঠিক আছে। ওকে ওকে, তোমরা রেস্ট নাও 5 মিনিট। কি বোর লাগছে নাকি? কি বলো? ঝেড়ে কাশো, ঝেড়ে কাশো। হ্যাঁ ছেড়ে দেবো, আমারও টানা হয়ে যায় অনেকটা। হ্যাঁ এটা নেক্সট স্যাটারডে লাস্ট এরকম দুটো হবে, তারপর থেকে ডিসেম্বর থেকে একদম দুটো। হ্যাঁ হ্যাঁ না, ওটাই আমিও করবো, আমারও সুবিধা হয়, আমারও মানে একটু স্ট্রেন বেশি পড়ে যায়। আচ্ছা এই ফ্যানটা একটু চালিয়ে দাও না। Yes. हाँ ठीक है। ওর কাছে ইন্টারেস্টিং লাগে নাকি জিনিসগুলো? ভালো লাগে তো, একটু কষে দেখবে তাহলে আরো ফিলটা বেটার হবে। গ্রুপ থিওরি খারাপ লাগলে তোমাকে, না গ্রুপ থিওরি যেটা পড়িয়েছিলাম আমি তো লরেন্স গ্রুপ পয়েন্টারের গ্রুপের পার্টটা পড়িয়েছিলাম, ওই পার্টটাই মেইন লাগবে, অন্যগুলো আপাতত লাগছে না। হ্যাঁ এসো, আমি তো আগে আজকে তো লাঞ্চের পরে ছিলাম, খালা গেছিল। যে 11টা তো অনেক দেরি, তুমি তার আগে চান টান করে নাও না। তোমার বাড়ি বলছিল ডায়মন্ড হারবার। সাগর দ্বীপের কাছে, কাকদ্বীপ। হ্যাঁ বড় বড় কাছারি না, ঠাকুরপুকুর বাজার। হ্যাঁ ঠাকুরপুকুর বাজার থেকেও 1 ঘন্টা, মানে জোকা পেরিয়ে নাকি। হ্যাঁ চিনি না, যাইনি আর, আমি ঠাকুরপুকুর বাজার অব্দি ম্যাক্সিমাম গেছি। Okay. না নেগেটিভ এনার্জি যদি মানে কি ইনসিডেন্ট তুমি বলছো, ইনসিডেন্ট করলে তুমি নেগেটিভ এনার্জি করলে তুমি এখানে, হ্যাঁ তুমি এখানে তোমাকে ভি দিয়ে লিখে ইউ দিয়ে লিখেছি তো ওখানে ভি দিয়ে লিখতে হতো না, এটা ইউ দিয়ে লিখেছি, ভি দিয়ে লিখতে হতো, এটা তো ইউ থেকে এলো মানে ভি দিয়ে আসতো। So transmitted wave has the form in the z going greater than 0, z positive region as this, as later. Trans z is equal to c to the power I qz 10 q by so I'm taking this as a solution. Q is the new pole momentum, whose z component is q itself, and in this region z going greater than 0. So in this region the potential has v, value v. So you have to calculate this denominator E minus V, E plus M will be replaced by E minus V plus M. Okay. Because Q will satisfy E minus V minus M square. Right? Q square plus M square will be E minus V whole square. That will be the total energy. Now, I can write down, so this is my psi incident, I'll take. Okay. আবার জোরে বলো, আমি কানে শুনি। না, আমি দুটো ইয়ে করছি, জেড গেটের একটা সলিউশন এদিকে যাচ্ছে, একটা সলিউশন এদিক দিয়ে যাচ্ছে। তাই আসবে আলটিমেটলি, মানে আলটিমেটলি দেখবো আমরা বিটা 0 হবে। আমি আপাতত আই কিপিং দ্য অপশন ওপেন। হ্যাঁ, কি বলছো? না, নেগেটিভ আমি এখন কনসিডারই করছি না, আমি পজিটিভের মধ্যেই রেস্ট্রিক্টেড রাখছি, স্পিন আপ আর ডাউন নিচ্ছি। হ্যাঁ, হ্যাঁ হ্যাঁ, যেটা ইভেনচুয়ালি হবে, যেটা আমি এক্সপেক্ট করি। হ্যাঁ, খালি তাই না, মানে মানে আমি যেটা দেখব যে এই যে জিনিসটা আছে রিফ্লেক্টেডটা, যেটা রিফ্লেক্টেডের এটাও তোমার 0 হয়ে যাবে বিটা, জাস্ট ফ্রম এটা হচ্ছে স্পিন ডাউন, মানে এটা যদি থাকতো রিফ্লেক্টেডের মধ্যে, এখানে স্পিন আপটা আসছে, এটা তো স্পিন আপটা আসছে, রিফ্লেক্টেডে যদি এই পার্টটা থাকে তাহলে দিস উইল রিপ্রেজেন্ট যে রিফ্লেক্ট হওয়ার পরে স্পিডটা ফ্লিপ করে গেছে। আমরা দেখবো যে এটা হবে না। লাইকওয়াইজ ওই ডিটাও 0 হবে, বিটাও 0 হবে, ডিটাও 0 হবে। So total solution I can write psi z for all z can be written as theta minus z okay. Total solution I can write like this. This solution is valid in this region, and this solution is valid in this region. Huh? This is a Heaviside theta function, step function. So now I take the limit, continuity of the equation, limit z to 0 minus of psi z should be equal to limit z going to 0 plus psi z. Okay. This should be same, and once you do that, you will find, because now z equal to 0 you are putting, so these all the exponent factor will become 1. Okay, now it is a straightforward exercise. You will get the following condition: 1, 0, k by b plus m, 0 plus a, 1, 0 minus k by e plus m, 0 plus b, 0, 1, 0 plus m equal to. See, now this I have taken into account, psi incident plus psi reflected, so I can erase this as c one 0 q by e minus v plus m, and 0 plus d 0, 1, 0. That's the condition we get. Okay. Zero 1 0 k by k plus m. E plus m. Okay. Now you compare top row. So is it clear to everybody? Just see. Now if you compare, so can I erase this part? 1 plus A is equal to C, B is equal to D, K by E plus M, 1 minus A is equal to C Q by E minus B plus M. And B K by E plus M is equal to minus B Q. Okay. Just compare, you'll get this. Okay. And to solve these equations, you get B is equal to D is equal to 0, no speed shift, one plus A is equal to C, and 1 minus A is equal to RC, where R is equal to Q by K E plus M E minus B plus M. R is this vector. Okay. Now, since Q is equal to E minus V whole square minus M square, now since Q is this, remember. So now if V is raised further, okay, okay, then E minus V whole square, just hello, হ্যাঁ 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 আচ্ছা আচ্ছা So I can raise V substantially high so that this quantity within the square root become negative, right? So it is square. Square ache. You can write a V minus C square also. Now M you cannot play. Given a particle its mass, you have no control on it. The control you have on the experimental situation, raise the potential higher and higher. তাই না? The potential কে বাড়াচ্ছ। একটা পয়েন্টে আসবে যখন এই এটা থেকে ছোট হয়ে যাবে। হ্যাঁ? If E minus V, then Q becomes purely imaginary. ঠিক আছে? In that case, what happens? This transmitted wave, e to the power iq, that thing, remember, I have erased it, transmitted iq, z was the factor because d was 0. C e to the power iq z times some column matrix. Q becomes purely imaginary. So it will, what happen? It will start decay. That's what happens in tunnel effect also. Okay, the same feature persists here also. If it were some finite length kind of thing, then after decaying it would have come out, then again it would have started oscillating. So you will get this what is called tunnel effect. But it is indefinitely long, then it decays and goes to zero eventually, asymptotically. Okay. So, transmitted wave. I'm not arrived at there. Wait, koro. However, if we increase V sufficiently so that sufficiently so that V is greater than E plus M. Then look at this place. V is greater than E plus M. So R becomes negative. Then R is greater than less than 0. And show now, this is your exercises. You can easily calculate the current J reflected will be greater than J incident. Show this homework. We will show the moment this happens, R becomes negative, we will find that the reflected current will be more than the incident current. This is a contradiction, no? This doesn't make sense. But it doesn't mean that conservation of current doesn't hold. Huh? Means by showing, show this homework, by showing, just so you see, if you bring this thing, you just have to show this. So R becomes, means you first show this thing, so R becomes negative, J transmission, it becomes negative. Okay? And this ratio becomes negative, there is a minus here. So it becomes plus, it exceeds more than 1. So J, this thing becomes greater than J ins. Okay? Incident, reflected. You can easily show this thing, calculate the current in the impulse relation. Okay. So it shows that if you stretch this theory to some extreme limit, it shows up some inconsistencies. So as a theory, it is highly incomplete. But if you are working in a domain where the potential is reasonably small, it doesn't go to that extreme, then you can get good first order relativistic correction over and over above the Schrodinger equation. Those are reliable. But you should not trust it as a complete theory, a rigorous theory. So this is another shortcoming for this theory. It's called Klein paradox. Reflected current exceeds that of incident current. Okay. Any question, Krishna Tiwari? হ্যাঁ বুঝতে পেরেছো? এগুলো নিজে একটু করে দেখে নেবে। হ্যাঁ রবেরটা কোথায়? সাতকাণ্ড রামায়ণ পড়ে সেটাকার বাপ হয়ে গেলাম। মানে রিফ্লেক্টেড কারেন্ট যদি এক্সিড করে ইনসিডেন্ট কারেন্ট থেকে, তাইলেই তো এটা ইনকনসিস্টেন্ট। যে আমরা ধরে নিয়েছি পার্টিকল নাম্বার ইজ কনজার্ভড, একটা সিঙ্গেল পার্টিকল তার উপরে দ্য মোমেন্ট ইউ হ্যাভ such a very high energy potential, you have to have the, you have to discuss about the particle creation in this case. So you have more than one particle created. Whole descriptions cannot be accommodated within the quantum mechanics. You have to have multi-particle description. So that quantum free field becomes is inevitable, and the description of such.
স্যার এক্ষেত্রে কি তাহলে কিছু পার্টিকেল অ্যান্টিপার্টিকেল ক্রিয়েট হচ্ছে সেক্ষেত্রে কারেন্ট বাড়ছে এরকম কোনো ব্যাপার?
আমি কিছুই বুঝতে পারি না। You have to take the trouble of coming to the class directly, physical class. I cannot follow anything. বুঝলে কি বললো? কানে একটু কম শুনি। ঠিক আছে, তাহলে আর কিছু আছে কি? বলো। বক্তব্য। হ্যাঁ? Client করেছে, client করে। Mr. Client। হ্যাঁ, যখন দেখেছে এরকম solitary equation যখন করেছিলেন, particle potential বেরিয়ে আসে। এখানেও লাগিয়ে দেখি কি হয়, এরকম inconsistency আসছে। There are some extreme situations যেখানে inconsistency shock হচ্ছে। Okay then. তাহলে বেরিয়ে যাচ্ছি আর কিছু নেই। এটা অফ করে নেব।